All right, here we go with our notes on radian measure. If you follow along with me, then this is going to be pages 28 through 30 in your notes packet. So far we've been talking about the unit circle and evaluating trig using degrees. But now today we're going to talk about radian measure, which is another way of evaluating these trig functions and dealing with the unit circle. Let's start with this warm-up. Suppose your car has tires with radius of 1 foot and the wheels are turning at a rate of 720 degrees per second. How far does the car travel in 1 second? Write the distance as a multiple of the radius. So, we know that if it's turning at a rate of 720 degrees per second, then it's completing 2 full rotations in 1 second. If 1 full rotation around the tire or 1 circle is 360 degrees, then 2 full rotations is 360 times 2, or 720. So from that, we know that the car is completing 2 full rotations of its tires. So the distance traveled, 2 full rotations around the tire, is going to be 2 circumferences. So if the circumference can be represented as 2 pi r, where r is the radius, then 2 full rotations around would be 2 times 2 pi r, or 4 pi r. So then the distance traveled in terms of its radius is going to be 4 pi r. Now suppose it has a tire with radius 3 feet and the wheels turn at a rate of 180 degrees per second. We want to know how far it travels in 1 second. So if it travels at a rate of 180 degrees per second, well, that tells us that we have 1/2 rotation of the tire. If a full rotation is 360 degrees, a half rotation is 180 degrees. So then we want a half circumference. So 2 pi r divided by 2 is just going to be pi r. So the distance traveled is going to be pi r, where r is the radius. So let's talk about degrees versus radians. Suppose you're running around a circular track, and you would never say that I ran, say, 40 degrees around the track. You would say something more like, I ran 100 meters around the track. You would talk about your distance traveled. Well, that's what we're discussing when we're talking about radians. We're talking about the distance traveled around the circle, and that is generally called arc length. Okay, so when we're talking about the distance around the circle, we're referring to arc length. Okay, so radians can be represented as the distance traveled divided by the radius. Okay? In the above examples, the rate you were given in degrees per second is known as rotational speed, or the speed that you are rotating. Okay, so if we're looking at this example here, we're looking at the speed at which the degrees, or the angle, is changing. Linear speed is the distance, the change in distance over time. Okay, so if we're looking at linear speed, we're looking at something straight like this. And of course, arc length is the same thing, but we can curve it around an arc. Okay, so where the rotational speed would be represented as degrees, the linear speed is going to be represented through radians. Okay, that's the distance around the arc. So if 720 degrees is 4 pi radians and 180 degrees is pi radians, how many radians is 360 degrees? Well, 360 is half 720, so that its radian measure is going to be half 4 pi, or just 2 pi. And that should look familiar. We also see that in our circumference formula, 2 pi r. It's 2 pi radians around the circle. All right, let's get some practice. Go ahead and flip the page. So now I want to convert these degree measures into radians. This first one, I have 80 degrees, and I want to make this into radians. So what I can do is I can set up a proportion. I can say that 80 degrees is to, say, 180, as our radian measure is 2 pi. So we're setting up a proportion, the degree measure that we have, to the degree measure 180, and we know that radian measure is pi. So we want the radian measure of 80 over the radian measure of 180, which is pi. So solving for x, we can multiply both sides by pi, and we have x equals 80 pi over 180. Reducing that fraction, we get 4 pi ninths. Now notice what's going on here. In order to find the radian measure of 80 degrees, we multiplied 80 by pi over 180. And we can do that to convert any degree measure into radians. We multiply by pi over 180. So let's go ahead and do that for the remaining two. We have 100 degrees. We're going to multiply 100 times pi over 180. We get 100 pi over 180, and reducing that fraction, we get 5 pi ninths. And that's the radian measure of 100 degrees. For 270 degrees, we're going to again multiply by pi over 180. And we get 270 pi over 180, which reduces to just 3 pi halves. Now we want to go from radians to degrees. So instead of multiplying by pi over 180, we're going to do the inverse. We're going to divide by pi over 180. And dividing by a fraction is the same as multiplying by its reciprocal. So to go from radians to degrees, we're going to multiply by 180 over pi. So let's do that. For 5 pi 6 radians, we have 5 pi 6 times 180 over pi. Well, you might notice the pi's cancel out. We can reduce 180 and 6 by a factor of 6. So 180 becomes 30, 6 becomes 1, and we're just left with 5 times 30. So the degree measure of 5 pi 6 is 150 degrees. For 3 pi fourths, we're going to do the same thing. 3 pi fourths times 180 over pi. Again, those pi's cancel. And we can factor out a 4 from both 180 and 4. So 180 divided by 4 is 45, and 4 divided by 4 is 1. So we have 3 times 45, that gives us 135 degrees. If we have just one radian, then we can take 1 times 180 over pi again. And we get just 180 over pi, which we can approximate. Well, pi is about 3.14. So 180 divided by 3.14 is approximately 57.30. So 1 radian, 1 radius, distance around the circle is about 57 degrees or so. All right, let's go ahead and tie this into the unit circle. So taking a look at this, we'll say that this is the unit circle, or really any circle centered at the origin. We call the positive x-axis our 0 degrees, so likewise we'll start there for our radians. That's 0 radians. Okay? We know 1 full rotation around the circle is 2 pi radians. So that would mean 1/2 rotation around is going to be half 2 pi, or pi. Half of that, so a quarter rotation is going to be half of pi. So that's going to be pi halves. And likewise, 3/4 around the rotation is going to be 3 pi halves. So those are all of our quadrantals. So we have 0 or 0 degrees, pi halves or 90 degrees, pi or 180 degrees, 3 pi halves or 270 degrees. Let's go ahead and draw in our 45 degrees. So we're going to cut this in half. And this typically would be our 45-degree angle, right? But now it's halfway between 0 and pi halves. So that's going to be pi fourths. And from here, let's just count up by pi fourths. So 0, pi fourths, 2 pi fourths or pi halves. Halfway in between pi halves and pi is going to be 3 pi fourths. 1 more pi fourths would bring us to 4 pi fourths, or just pi. Another pi fourths would be 5 pi fourths. Another pi fourths would be 6 pi fourths, or 3 pi halves. Another pi fourths would be 7 pi fourths. And again, these correspond with our multiples of 45 degrees. If we're in terms of degrees, these are our multiples of 45 degrees, or multiples of pi fourths. All right. So we know we've got more than just our 45 degrees. We've also got our 30s and 60s. Well, let's look at 30s. So if we go up 30 degrees, 30 degrees in radians is going to be pi sixth, right? 30 is 1/6 of 180. So pi sixth is 1/6 of pi. Okay. We're going to go up another pi sixth. That's going to be 2 pi sixths or pi thirds. And pi thirds corresponds with our 60 degrees. Go up another pi sixth. We have 3 pi sixths, or that's pi halves. Go up another pi sixth. We have 4 pi sixths, or that reduces to 2 pi thirds. Go up another pi sixth. That's 5 pi sixths. Another pi sixth would be 6 pi sixths, or pi. Another pi sixth would be 7 pi sixths. Another would be 8 pi sixths, or 4 pi thirds. Another would be 9 pi sixths, which would be 3 pi halves. Another would be 10 pi sixths, or 5 pi thirds. And the last but not least is 11 pi sixths. So these are all of our radian measures around the unit circle that give us special right triangles. I want to tie this into degrees, so go ahead and pull out another color. 0 is going to be our 0 degrees. 2 pi is going to be our 360 degrees. Pi 6 we mentioned is our 30 degrees. Pi fourths is our 45 degrees. Pi thirds is our 60 degrees, right? It's 1/3 of 180 degrees. Pi halves is going to be our 90 degrees. 2 pi thirds is our 120 degrees. 3 pi fourths is our 135 degrees. 5 pi sixths is our 150 degrees. Pi is our 180 degrees. 7 pi sixths is going to be our 210 degrees. 5 pi fourths is going to be 225 degrees. 4 pi thirds is going to be our 240 degrees. 3 pi halves is our 270. 5 pi thirds is our 300. 7 pi fourths is our 315. And last but not least, our 11 pi sixths is 330 degrees. Okay? With more practice, you'll become much more familiar with the unit circle and its radian measures. All right, let's get some practice. Go ahead and flip the page. So now I want to talk about coterminal angles. Let's start off with an example that we probably have seen before. We've got negative 100 degrees, and I want a positive and negative coterminal angle. Okay, so coterminal means that we land at the same spot. So negative 100, in order to find a coterminal angle, we can add or subtract multiples of 360 degrees. So let's subtract 360 degrees, and we get negative 460 degrees. That lands at the same spot as negative 100. To find a positive one, we'll add 360 degrees, so we get positive 260 degrees. Now for radians, we know one full rotation around is 2 pi. So we're going to add and subtract multiples of 2 pi to find coterminal angles in radians. So pi thirds, we're going to subtract 2 pi, or we could subtract 6 pi thirds. So pi thirds minus 6 pi thirds would be negative 5 pi thirds. Adding 2 pi or adding 6 pi thirds would give us 7 pi thirds. For 2 pi sevenths, we can subtract 2 pi. So 2 pi is also 14 pi sevenths. So subtracting 14 pi sevenths, we get negative 12 pi sevenths radians. And adding 14 pi sevenths, we get 16 pi sevenths. For 3, we can, again, add or subtract 2 pi. So we have 3 minus 2 pi as an exact value. Well, 2 pi is about like 6.28. So 3 minus 6.28 is approximately negative 3.28 radians. And then adding 2 pi, so 3 plus 2 pi, again, 6.28 for 2 pi, we get 9.28. So there we found some coterminal angles, both positive and negative, in radians. Let's go ahead and evaluate these trig functions below. We're going to start off with a couple in degrees, just as a review. So in order to evaluate the tangent of 240, I'm going to find 240 on our unit circle. Well, 240 is in quadrant 3, so we're going to draw in the angle in quadrant 3. The reference angle, that positive acute angle made from the terminal ray and the x-axis, is 60. I'm going to choose a point a distance 1 from the origin and drop a perpendicular. So we have across from 60, we have negative root 3 over 2. Across from the 30 is negative 1/2. And notice they're both negative because we're in quadrant 3. Well, tangent, we know is the ratio of the opposite over adjacent, or this would be with the y-coordinate over the x-coordinate. So we have negative root 3 over 2 over negative 1/2. Dividing by a fraction is the same as multiplying by the reciprocal, and we get positive root 3. Secant of 180, well, 180 degrees, that's one of our quadrantals. That lies on the negative x-axis. So this point here is negative 1, 0. So the secant is 1 over the cosine, or 1 over x, which tells us we have 1 over negative 1, or just negative 1. Let's try some radians. So here I have sine of 3 pi fourths. Well, 3 pi fourths, the first thing that we have to do is identify which quadrant we're in. 3 pi fourths is less than pi, but greater than pi halves. It's right in the middle, so we're in quadrant 2. Our reference angle is always going to be whatever we're dividing by. So pi fourths, pi over whatever we're dividing by. For special right triangles anyway. So we have pi fourths. We're going to choose a point, distance 1 from the origin, drop a perpendicular, and we have, remember pi fourths, that corresponds with 45, so we got a 45, 45, 90 triangle. So the legs of the isosceles right triangle are root 2 over 2. Horizontal in quadrant 2 is negative. So then the sine corresponds with the y value. So that tells me that it's root 2 over 2. The cotangent, 5 pi thirds. So 5 pi thirds, that's greater than pi. That's greater than 3 pi halves. So 5 pi thirds is in quadrant 4. Our reference angle is going to be pi thirds. And that we find here. You can always take 2 pi minus 5 pi thirds. The shortest, that acute angle to the x-axis, you can always take that difference. Okay, so across some pi thirds, that's our 60-degree angle, is root 3 over 2, and that's negative. Across from our pi sixth, or 30-degree angle, is 1/2. Cotangent is the ratio of the adjacent over hypotenuse, or adjacent over opposite, x over y. So we have 1/2 over negative root 3 over 2. Dividing by a fraction is the same as multiplying by the reciprocal. So we have 1 over negative 1 over root 3, or negative root 3 over 3. Got 2 more examples. Cosecant of 7 pi 6. Well, 7 pi 6 is greater than 6 pi 6, so we know that it's greater than pi. It's particularly 1 pi 6 greater than pi. So we're in quadrant 3. Drop your perpendicular. Our reference angle is pi 6. Across from pi 6, we get the 1/2. That's negative. Across from the pi thirds, or the 60-degree angle, we have root 3 over 2. Again, negative, quadrant 3. Cosecant is 1 over the sine, so 1 over y, which gives us 1 over negative 1/2, or negative 2. Let's try this last one. We have cosine of negative 3 pi halves. So remember, negative angles, we want to go clockwise around the plane. So negative 3 pi halves, we're going to go negative pi halves, negative pi, negative 3 pi halves. So that's a quadrantal. All right, so the coordinates on the unit circle for this is 0, 1. Well, cosine corresponds with x, which is just 0. All right, these are our notes on radian measure. We're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day.